The traditional concept of web development from 10 years ago was page-oriented. When you build a website or an application, you would think in terms of pages, how many pages you need, how they should relate to each other, etc. Every single page may have its own JS, CSS dependencies, or global dependencies, depending on features and functionality. So finally, the page may end up with something like this. This solution is hard to scale because loading too many scripts can cause a network bottleneck, right? The second option is to use a big JS file containing all your project code, but this leads to problems in scope, size, readability, and maintainability. And when you need to deploy the app, you have to copy all of the HTML, JS, CSS files to a production environment, which might be dozens or even hundreds of files. And lastly, to host all of your application files, you need a server, right? Which can manage the folders structure, handle routes, and so on. Now, we are in a component-based web development era. As you can see here, each component is a piece of UI. We can build these components in isolation and then put them together to create complex UIs. Some benefits are, it allows for code reuse, it ensures UX consistency across a portfolio, and it is state-driven. And then package the application with the help of bundlers such as Webpack, Parcel, Fusebox, and Rollup. Those bundlers are included out of the box in JavaScript frameworks. But what's common among these frameworks is that the bulk of the work is in the browser. A few years ago, Jed Smith at Brooklyn Meetup explained his vision of next generation UI framework. And he says, the apps we write are direct grabs, but the runtime we have is a tree, the DOM. So writing an app should be just writing a graph. And the compiler would figure out where the dipoles are and rig up the DOM event code to make that relationship consistent across state. And then there was this smart guy, goes by the name of Rich Harris. Listening to Jed, suddenly he had this epiphany. Frameworks are not tools for organizing your code. They are tools for organizing your mind. They often help you write better code, but their true value is in the way they help you structure your code and express them. So, what if a framework wasn't a thing that ran in a browser at all? What if it was a compiler? My name is Devlin Duldulao. I'm a senior consultant at Meta. I'm here to talk about Svelte, cybernetically enhanced web apps. So, what is Svelte? Svelte is a radical new approach to building user interfaces. Whereas frameworks like React and Vue do the bulk of their work in a browser, Svelte shifts that work into a compile step that happens when you build your app. And rather than applying techniques like virtual DOM diffing, Svelte writes code that surgically updates the DOM when the state of your app changes. Svelte is written by Rich Harris of the New York Times in late 2016. Now Svelte is in version 3. So how does Svelte work? Svelte has taken inspiration from observable in the way it runs your code. But first, let me step back and ask you, what is reactive programming? This is reactive programming from Wikipedia, but to make it short, reactive programming has key similarities with the observer pattern commonly used in OOP. I'm assuming you have encountered pub/sub design at some point. To differentiate observer from publish, subscribe, observers are aware of the subject. Here it is. Also, the subject maintains a record of the observers, whereas publisher, subscriber, they don't need to know each other. Here's a spreadsheet. Reactive programming, what makes a spreadsheet so intuitive. When you make a change in a cell, all the cells that depended on it, change too. This is what Svelte does by default. Svelte brings reactivity to JavaScript itself. So now let's jump, see how does Svelte work. Okay, so yeah. So you write a normal JavaScript code, but you need to follow certain syntax. So enhance JavaScript, your code. And then when you run the Svelte compiler over your code, it compiles that code to optimize runtime instructions. So here it is. You were probably saying right now, is this important? Pre-compilation can significantly lower the overhead of a framework. So let's check this out. Take a look at this. Svelte did away with this typical scenario because apparently there's a performance penalty with frameworks that don't pre-compile. This is due to compilation translation that happens on the client side before any of the actual app code can be run. And here we're in change detection. Let's review how Angular, React, and Vue detect changes in their app state. Here's Angular's dirty checking. One of the performance characteristics of this is that it is bound by the cost of watcher computations here. Here's React reconciliation, performance characteristics, bound by render and diffing costs of dirty subtree. There it is. And here's Vue. It's like virtual DOM plus dependency tracking. Performance characteristics, it's balance, balance update efficiency. So yeah, Svelte has managed to bypass the virtual DOM here. Diffing is not free. You can't apply changes to the real DOM without first comparing the new virtual DOM with the previous snapshot. It has unnecessary computation. So how does Svelte do change detection? Svelte does change detection differently here. Svelte component code will be compiled into vanilla JavaScript with code detection already in place. Okay, so this is almost exactly the update code that Svelte generates. Unlike traditional UI frameworks, Svelte is a compiler that knows at build time how things could change in your app. Things could change in your app rather than waiting to do the work at runtime. Here, it generates code like this. So it knows that the only thing that could ever change here is the age here. So this is the whole update function it generates for this piece of template here, the h1, im, and then age. Svelte is able to infer a lot more about your intention, what your components are trying to do. Pre-compilation and avoiding virtual DOM what makes Svelte performant when it comes to memory allocation. Here's a JS framework benchmark. Svelte is the first green column here, as you can see here. Followed by Vue, React, and Angular. It shows that Svelte is the performance winner among the four, but take it with a grain of salt. There might be an implementation inaccuracy here, things like development versus production mode, not applying framework-specific optimizations, and unintentional errors, of course. So continuing. And now you only ship the code your app really needs. Now let me show you how small Svelte can be in comparison with other frameworks. This is a benchmark from FreeCodeCamp, real-world comparison of front-end frameworks with benchmarks 2019 update. They've used Conduit's real-world app repositories. Real-world means can do CRUD, send HTTP requests to a backend, and has authentication. What you need to know here is that the smaller the file, the faster the download and less to parse. So Svelte is, again, the winner here. So yes, Svelte can produce extremely lightweight code, but why should you care? You should care because it can be extremely fast. It uses very little memory. It can be used on embedded devices, which you'll see in a bit. So here in Adi Osmani's presentation, Adi Osman is a developer from Google. He talks about keeping your JavaScript bundles small, especially for mobile devices. Why? Because small bundles improve download speeds, lower memory usage, and reduce CPU costs. On mobile, you want to ship much less, primarily because of the network speeds, but also to keep plain memory usage low. That's right. He also mentioned that JavaScript execution time is important for phones with slow CPUs. It's also right. You also have to consider, due to differences in CPU, GPU, and thermal throttling, there are huge disparities between the performance of high-end phones and low-end phones. This matters for the performance of JavaScript, as execution is CPU bound. Okay, here, therefore, in the browser, that compiled code executes and then renders the user interface. Okay, shifting the load to compile step can also be seen in other frameworks nowadays, like this one, Stencil. And then the other one is Solid.js of Brian Carniato. So to try Svelte, you need a Node.js runtime, npm. You just run npx digit svelte.js/template and the name of the directory or project. Go to that directory, npm install, and then npm run dev. Okay, demo time, finally. So let me just open up my VS Code here, and then your displays. Okay, so here I have a Svelte here, the starter project Svelte template. And let's check out what's inside of this package.json. So yeah, we have scripts here, build, dev, start, using rollup here. Rollup is the default module bundler of Svelte. And you'll notice that most of the npm packages are inside these dev dependencies. Because this is a compiler, it doesn't need any dependencies during runtime, right? But you'll see these serve CLI dependencies, the dependency for running the app. In this here, this public here folder. So basically, that's what's inside of the package.json. Let's close this. So, okay, so next is let's run this app. Oops, where did it come from? Yep. And then go to localhost 5000. And this is the default UI of the root component here. So this is the root component. Let's check this out. Okay, so in Svelte, this is how you would write UI in Svelte component. There are three sections here, parts: the script for your JavaScript, the template for Vue, and then the styling here. So yeah, it's like VueJS, right? But one thing that makes this different from VueJS is that you can do this. Let's see. In VueJS, it has to be inside this template parent element, right? You cannot do this. So in Svelte, you can basically add two or more elements here. So let's remove this, delete this also, the styling, as well as this. Make it clean slate. And let's check out this main.js. So this is the app component being instantiated, and that's the world from the hello world being passed as a props. Let's delete this also. We don't need that. Okay, so how do you create a component in Svelte? So let's try here. Just naming convention is Pascal case. Let's try title, and then the extension name, Svelte. And just, let's say, NDC London. And here, you just need to import that component. And then here, just like that. So NDC London. So what if I have a state here from the parent component and I want to pass it down to the child component? So let's create another component here. This time let's name it each, because I'll be writing a loop, a looping control flow here. Say script for each, and here. Okay, so R for array. Say name could be, say Carl, and this one ID to name it Richard. So yeah, we have an array here, and we're going to pass it here. So here, let's create also an array. Say name it my array, and then this is how you would write an if-else control flow. This is if my array is not empty, and to close that, slash, then if else would be colon else, then just put there it's empty. And here, of course, we need to add something here. Let's say gonna loop inside this array here. So that means each in its belt. And to close that, each. And of course, it needs an array here. And then as name could be anything you want. Let's name it obj. And here we can access the index of this object here inside of the array. And then, oops, you can just use it here. Name, right? And then just to create a list with numbers. And you also need to add a key here, just like in Vue.js and React. You need the key. That would be any properties that different or unique. So that's it. So this should work, you think? So each, and here. And we need to pass, right? Pass my array, right? And then, yep. That should work? No. Forgot something. Here, you need to expose this to other elements or to other components. And to do that, you need an access modifier, but it's not gonna be public, no. It's export. Oh, there you go. So that's it, just export. So we have this feature. So let's create another component and then show you another feature in Svelte. So here, let's create a form component script. Basically, this will have an input. So maybe first name here. And then let's initialize it with empty string. And then welcome first name. It's like that. And then the input here, let's try to import again. Okay. So form. Okay, here it is. This is a one-way data bind. So in input, if we want also to bind it, of course, we have to use the attribute value here, right? And then just pass this variable here. So we have one-way data binding. The problem is, of course, it's one way. If we edit this input here, that wouldn't, update the text here. So you need at least two-way data binding. To do that, you just need to prefix this with bind and then colon. That would make it two-way data binding. Simple, right? Okay, another one. Maybe, okay, so let's add some styling here. So you would see how, how we would style in Svelte. Let's just name it welcome. And then, of course, the styling should be here. Could be anywhere, I mean, you can put it here or here. Doesn't matter. Welcome, color, dark orange, like Svelte. So, yeah, there you go. There's this styling here, as you can see. Same as the old HTML, CSS. What if this is empty? How will I, turn it to dark again? Like disable this. So there's the class directive in Svelte. This is how, it's being done. Welcome, and you just need to pass a Boolean here. So we can use this first name here, right? Like so. And then if this empty goes to, this thing doesn't get activated, but as soon as you start typing something here, it gets activated. So yeah, that's a class directive in Svelte. Okay, so let's try another one. Maybe this one, computed. We'll just compute something. Actually, just adding two variables. Okay, so food. And then what? Rent. Here. And then let's say total expense, USD, total X, maybe just total, be enough. Here you go. Then put it here. This should work. Let's try to import that. Computed. Here it is. Where's it? This one. So, okay, so what if I want to, this automatically gets updated every time I change this? So let's just use a button here. Let's name it increase. And then to add a click event in the button, you just type on, colon, and then click. And then food, get the current, and then add 10. Just copy this. And then, yeah, decrease. Okay, so how do we make this reactive? Because right now this is not reactive yet. So in Svelte, there's this JavaScript labeled syntax here, and Svelte is using it as a reactive statement or reactive declaration. So basically, this is now reactive, and it watches for any changes from these two variables. So you get this. Now it's reactive. So are there any Angular developers here? React developers? VueJS developers? That's good. In Angular, you would write it like this, right? Let me check if I'm still, in Angular, I did a lot of Angular before. It's a getter function. This is how you would write it, right? Plus this, and then rent. That's making it reactive, the total. In VueJS, you need to put it inside this computed, and then write the name of that computed value, and then function, right? So this is how you would write it in Svelte. So, yep. I also did some Vue.js application before in native script Vue.js. And in ReactJS, the first thing that came up from my mind is using a MobX library. This more, it's simpler than creating your own. So in MobX, in ReactJS MobX, you would write it like this: computed get total, food plus, right? This is how you would write it in ReactJS. So as you can see, any of this versus this one. Actually, if you go to Svelte website, there are 3 boxes here. It says write less code and truly reactive. So yeah, it's I know. You know that it's true, as you can see here. So let's delete this. We don't need this. And what else I can show to you guys? Maybe this one from Svelte on mount. This is basically ng on it in Angular. In Vue.js is mounted. In ReactJS, component did mount or use effect. So here, just use it like so. And then let's just replace this here. And then let's turn it to 0. That should work. See? So this is your lifecycle hook event where you can, insert your HTTP requests to your backend. It's the best place to put there. What else? Maybe transition. So let's create another component. We would need to bring in Svelte transition, and then fade and then fly. Yep. What else? We also need something here. Say visible, false, variable, and then just tells if this is true. Show this. So we need a button here, to switch the value of this visible to its opposite value. Let's name it toggle. And then again, on click, It's not that hard to remember. Okay, gosh. Oh my God, where's it? Yeah, I think this is right. Visible, then the opposite of visible, right? So here, okay, just a message, like say Superman. And then here, we can use this flyer and this fade. And there's an attribute that you can access in. This is the beginning of the transition of the UI. So you can use fly here, and then pass an object. That object requires you to like mark a position. Let's say x-axis will be 300 positive, and then the duration be just 3 seconds. And then of course the out here. Let's use fade, and doesn't need any location, just the duration. Yeah. Here it is. Let's try to import it here. Okay. That would be toggle, and then toggle. So let's try it. Fly in, fade out. Another one, fly in, fade out. So yeah, I'd like to show you another one, but it would take me another 30 minutes to explain it. And that's this state management in Svelte. So Svelte has a built-in store where you can use for state management. So tomorrow I'll be having a mini workshop, a 2-hour mini workshop. Please come to my workshop, bring your laptop so you can code along with me. We will write a real-world Svelte application. We'll be using a navigation here, material UI, what else? Store, of course, the store, and explain you how it works. What else? You'll writing tests for your component using Svelte testing library, and send HTTP request to a fake backend or fake web API. So basically, the real world, except authentication and authorization. Okay, yeah, that would be tomorrow, 10 in the morning. So, okay, so just let's go here to the Svelte website. I'll just show you the rest of the APIs here. You can just go here. There's the reactivity here, props, logic. I can also, okay, so tomorrow I'll be also adding these await blocks, events here, bindings, lifecycle on destroy for, before leaving or before destroying the page or closing the page or moving to another component or pages. And the stores here, motion, transitions, we just use this, animations, easing, SVG, and a lot here, actually. So here, this is the animation of Svelte. So you can see, you get this out of the box, quint out, crossfade, flip. So guys, this is not usual in component UI libraries because the authors don't want to increase the file size of the web applications that are built using their component UI libraries. But that's different in Svelte. In Svelte, it's a compiler. The authors, they don't care how many features they would include in the library, because this is a compiler. The application, the compiler itself, will just ignore everything that are not in use. So yeah, that's the big advantage of Svelte. So let's go back to the slide. Okay, here. Okay, real-world applications. So Svelte is being used for POS systems in Brazil. There's these 200,000 devices in the wild. That device runs a very old WebKit on extremely memory-constrained hardware. They tried like a dozen different kinds of frameworks. None of them can be used because when you press a button, it would respond half a second later. Of course, users will be more likely to press it twice and may end up overcharging the customer. But when they tried Svelte, it works smoothly. Moslab is a company in Russia that uses Svelte to build applications for smart TVs. So yeah, here's what you can notice here. POS and smart TVs are all pretty low-powered devices, right? And this is a trend that is only going to increase. The new frontier is the embedded web, wearables, Internet of Things, in-car entertainment systems, smart home control panels. All of these things that have displays, they need UIs, and a lot of the time, those interfaces will be built on the web, right? What else can Svelte offer? Server-side rendering, SSR, can speed up the first render of your app and improve its SEO. This is similar to Next and Gatsby in React, Next and VueJS. Okay, so Svelte native, you can write a mobile application using Svelte. Okay, so let me show that to you. I have another IDE here, VS Code, and then this one. So this is Svelte on top of our native script. So you can see code, what else? Sleep. It works smoothly, Delete, mark completed. So that's Svelte in native script. Okay. And lastly, you can also use Svelte to build WebGL apps. You can go to this site, SvelteGL demo search. So yeah, let's weigh in the bad parts and the selling points of Svelte. Bad parts, TypeScript is not supported yet. Small community, few third-party libraries, lack of dev tools, no big company backing, very few jobs are available out there. But you know what? Angular, React, and Vue had similar history before. It's just a matter of time. You can start introducing Svelte to your boss or to your managers, and these are what you need to enumerate when talking to them. Selling points, easy to pick up, better performance, write less code, extremely small bundles, reactive out of the box, right? Declarative transitioning and animation, and best for low-powered devices. References, Svelte, Sapper, Svelte native, and Solid.js, another JavaScript compiler, UI. Stencil, what else? Testing library, Svelte testing library for writing for testing your components. Svelte also has a Discord channel if you want to talk to other Svelte developers around the world. You can go to this Discord channel. Gitter, I don't know how to pronounce that. Or for rollup, if you have questions or you want to discuss something about rollup, you can also go here. SvelteJobs.dev if you want to see how often you can see receive jobs or companies looking for Svelte developers, you can go here. And I highly recommend you guys to watch Rethinking Reactivity of Rich Harris. He describes Svelte far better than I ever could. And yeah, so if you want to live in Norway, if you want to move to Norway, we're hiring. Here's my email. And can I get a selfie, guys? With you? So it's gonna be quick. So say hi. Thanks. Okay, so I'll hang around for questions. Please don't hesitate to approach me later. Thank you guys for listening. Hope you like it.